All right, in part 1, we covered the foundation, cable size, current carrying capacity, the cable types you'll actually see on site, so now you know what the cable is. But that's only half the story. Cable selection isn't just about size, it's about how and where it's installed. This is where most mistakes happen. In part 2, we go beyond the label on the drum, into installation methods, temperature effects, mechanical protection, IP ratings, fire safety, voltage drop, and BS 7671 compliance. This is where cable selection stops being guesswork and starts being proper design. Section 2. Installation method and temperature. Heat is the biggest factor in cable performance. Electricity flowing through copper produces heat. If that heat can't escape, the conductor temperature rises. Standard PVC cable in the UK is typically rated at 70 degrees Celsius conductor temperature. XLPE cable is rated at 90 degrees Celsius. But that doesn't mean you can install it in a 90-degree environment. That rating refers to the internal conductor temperature under load. If the ambient temperature in a loft hits 40 degrees Celsius in summer, you've already reduced the cable's ability to carry current. BS 7671 includes temperature correction factors for this reason. Same applies if the cable is surrounded by insulation, it's grouped tightly with other circuits, it's installed in conduit, it's in trunking with multiple loads. Installation method changes everything. And this is where real cable design happens, not guesswork. Section 3. Mechanical protection and safe zones. The twin and earth. Standard domestic cable. Perfect inside walls. Perfect clipped direct. Perfect above ceilings. But under BS 7671, if you install a cable within 50 millimeters of a wall surface, it must either be in a prescribed safe zone, be mechanically protected, or be RCD protected. Now let's talk about burial. Would I bury twin and earth directly in the ground? No.
No!
Because it has no mechanical protection. That's where SWA, steel wire armoured cable, comes in. The armour provides protection against impact and damage, suitable for underground runs, external installations, areas with mechanical risk. But even then, it must be correctly glanded, correctly earthed, installed at correct depth if buried. Mechanical protection isn't optional, it's part of compliance. Section 4. IP ratings and environment. IP stands for ingress protection. 2 numbers. First number, protection against solids. Second number, protection against water. IP20, indoor dry areas. IP44, splash resistant. IP65, dust tight and water jets. IP68, submersible. Important point. Cables themselves don't usually carry the IP rating. The enclosure does. You can run a cable externally, but if the junction box is only IP20, water will get in. In bathrooms, outdoors, plant rooms, you must think about glands, enclosures, entry points, ceiling. The system is only as good as its weakest point. Section 5. Fire safety and support. BS 7671 also includes requirements about fire safety. Cables must be supported so they don't collapse prematurely in the event of fire. That means no relying purely on plastic clips in escape routes. Metal fixings are now required in many situations to prevent cables falling and creating hazards during a fire. There are also requirements around fire stopping. When cables pass through walls or floors, fire resistance must be maintained. In certain installations, especially escape routes or public buildings, cables may need limited smoke emission or fire-resistant properties. So cable selection isn't just about current, it's also about life safety. Section 6. Voltage drop. Voltage drop is another regulation requirement. Over long runs, voltage drops along the cable due to resistance. If the drop is too high, equipment may not operate correctly, motors may struggle, lighting may dim. BS 7671 sets limits for acceptable voltage drop in installations. So, on longer runs, especially submains or garden buildings, cable size is often increased not because of current, but because of voltage drop. Now for this last section, where cables should not be used. Let's summarise practically. Twin and earth, good inside walls, not good buried directly, not ideal exposed externally without protection. SWA, good underground, good outdoors, but don't bend tighter than its minimum radius. Don't skip proper glanding. Flexible cable, good for equipment, good for temporary supplies, not for fixed wiring in walls. Every cable has a purpose. There is no one-size-fits-all cable. Cable selection comes down to 5 things: load, heat, environment, mechanical protection, compliance with BS 7671. If you understand those 5, you're not guessing anymore. You're designing properly.